Welcome back. In lecture 24, we will continue with accessibility. So this is the second part of the accessibility lecture. So the different concepts that will be covered are spatial separation measures, cumulative opportunity measures, gravity measures, log-sum utility measures, and time-space model. And these are the different ways Bhatt has actually divide or categorize the different kinds of accessibility measures, and we would look into how different people have developed different forms of equations which have been used to generate these kind of measures. So in spatial separation and graph theory, so this is more of spatial separation measures are more or less related with graph theory, and distance, it's a distance based simple accessibility measure. We have already discussed it yesterday in the last lecture, and primarily it's a mobility measure, and it's because it's a mobility measure, it's primarily depends on the transportation or the travel times, and so we can call it a network accessibility measure, and where weighted average of travel times to all other zones is used to determine the accessibility of a particular zone. So AI is equal to Dij, summation of Dij. So that means from I to all other zones, from zone I to all zones j, and divided by B, where Dij is the distance between zones I and j, and B is the general parameter. So this is the basic form of the network accessibility measure or the spatial separation measure, and this is closely related with graph theory. And in the last lecture we talked about different centrality the ways we can measure different kinds of centrality, and this is the same thing. And in a transportation network composed of links and nodes, accessibility could be also measured as a degree of nodes, degree centrality, and number of links originating, which is basically the number of links originating from a node, and accessibility increases with the more number of links, and then number of links from a node to the furthest node, where lower values have higher accessibility, and then summation of links between a particular node and all other nodes, which is developed by Schimble, and it's called Schimble's accessibility measure. So here basically we are looking at the structure of the network, the number of links and nodes, based on the arrangement of the links and nodes, we can develop some measures of accessibility for each node. So that's a basic form of a network accessibility measure. So other researchers have also developed different forms of this particular measure, where Allen, Liu, and Singer have developed this particular form, where total accessibility, overall accessibility for an area A total is equal to 1 by n into n minus 1, which is basically we are normalizing the values, and we are having a summation of all the travel time between locations I and j, that is Aij. So for that means we are first adding up all the values and then dividing by n and n minus 1, which is actually normalizing the values. And then Guy in 1983 has given this particular form, where he proposes the Dij of k, that is Euclidean distance to a shop j in which goods k is available, and Ek is divided by summation Ek is Ek multiplied by Ek divided by summation of Ek, where Ek is the mean expenditure per household on goods k. What it means is, first of all, we are now trying to determine accessibility as per the different forms of goods. For example, people go for shopping for different things at different distances or different locations, and accordingly it's not a uniform measure of accessibility. So we are now categorizing that. So when we are talking about distance for each kind of trip, for buying each kind of goods, we are measuring it separately and then summing it up. So that is why this equation is in this particular form. Then Savignayer has also shown the accessibility in this particular form, where Gij is equal to measure of demand on trips between zone I and j, and Tij is the travel time between zones I and j. So here we see the introduction of travel time, which actually is, so this is basically opportunity, and then this is travel time. So this is gradually going to the form of measure where both transportation as well as the opportunities or the land use components are being getting incorporated. So this is one form which is some kind of a transition between this graph theory or spatial separation measures and other form of measures. So the next type of measures for accessibility are cumulative opportunities measures, where potential opportunities OT or activities within a threshold time t, that is travel time or distance, that is what determines the cumulative opportunities which are available within a certain time threshold. So AT is equal to summation of OT, and based on this t value, that means when we have a change t value, that means more number of opportunities becomes available, and accordingly we can develop isochronic maps which could be created by increasing the values of t. And this kind of measure is primarily used for measuring the number of employment opportunities. Like for example, if I am looking for a job which is maybe for blue collar workers, in that particular case what happens is many people are looking for jobs near, like a technician or a plumber. He is mostly looking at jobs which are near his house. So in this particular case, probably this measure will help, because he wants to understand how many kind of opportunities are there around his residential area, so around his location where he stay. So this kind of measure is primarily used for measuring the number of employment opportunities, and some form of disaggregation is possible. That means we can also divide this into different forms of employment. We can do it as per the income brackets. That means different income bracket, because people belonging to different categories of jobs actually also have different incomes. So accordingly we can also differentiate, and we can also do it gender wise, because certain we may also find some researchers have found that women are more likely to have a job near their location, whereas men can have a job far away from their location, so residential location. So that may play a role. So these measures can be used as exploratory variables in other models like location choice as well, and we will come to location choice models in the next lecture. And that means this in location choice models, people actually use this kind of measures to understand that what opportunities are there around. So accordingly they will also locate themselves in a particular area. And we can see that this actually just measures the opportunities. Behavioral dimensions are missing. That means the socioeconomic characteristics and all the other things, like Weibull introduced something like car ownership, like different people with different car ownership have different accessibilities in cumulative opportunities. So that also plays a role. So those dimensions are missing. And same effect for near and far opportunities. That means if an opportunity, I was discussing it in the last lecture, that there are shops near to my residences and then there are shopping malls far away. So overall accessibility remains same. So same effect for near and far opportunities. So this was actually shown by Handy, that we can use a distance decay function to give some weight to these particular opportunities. That means far away distances, opportunities like a shopping mall, they could be weighed with a different distance. That means there the effect of travel may not be that much, whereas the effect of travel would be higher in case of local shops. So these are some forms of this kind of cumulative measures, opportunity measures, and we can see the first form by Wax and Kumagi, where this Pijk is the proportion of workforce of zone I in income category J and occupation category K. So we are first only looking at the particular category of workforce of course in one zone I, and we are looking at opportunity. It's a accessibility measure for zone I, and we are looking into occupation category K as well as income category J. So we are actually subdividing the workforce into using these two variables, income category as well as occupation category, and then we are multiplying that with employment opportunities in hundreds in income category J, occupation category K within T minutes of zone T. So what it means, and then we have a summation of over all this. That basically means we are looking at every income category and occupation category and the opportunities or the number of jobs available in a certain distance for this particular group of people, and we are multiplying that, and then we are doing it for all the groups, and so we are summing over here for both j and k, and then we are finding that, and we are dividing by 1 by 100 and then we are finding the total accessibility within that travel time. So that is the first form, and then this is Weibul's equation. Here AI again is accessibility for zone I, where we are summing over for j equal to 1 to n. QD is basically over here, and this is 1 where d is lesser than equal to t, and 0 for d is greater than equal to t. That means the travel time that we are talking about, and Ej divided by small ej. So here Ej is the number of jobs in zone j, and where small ej is equal to this particular equation. Now in this equation what we can see, there is h, there is d, and then there is p. So h is population in a zone of for car owners the value is 1, and non-car owners the value is 2, and d is travel time via auto or transit. So basically we are multiplying car owners with we are assuming that this is h, and then d is basically the travel time by auto or transit, and then p is the non increasing function calculated from empirical data such as p 0 equal to 1 and px tends to 0 as x tends to infinity. So these are empirical formulas, but what it means is this is travel time into the population having that particular mode. So we are introducing a mode, the mode and that particular travel time in this particular form. So for each travel time and each mode, the measures are separately, these are calculated separately, and then we add up, and then we get the value of Ej. So this is how Weibul has given the form. Then Wikstrom has given the form where B is equal to summation of Pi into ORI, where Pi is the proportion of regional population in zone 1 to n of in each zone, and B is the measure of balance with an optimum value of 100, and ORI is the ratio of actual to desired opportunities reached within a given travel time for zone I, and where ORI again could be measured using this equation. Now this is interesting, where we see that OPIM is basically actual to desired opportunities reached in a given travel time for a purpose. So here we are trying to also understand what people want and actually what value they are getting there. So that actually has a role to play in their accessibility value. And M is the relative use of mode M. So again mode is considered, and QP is the relative magnitude of different trips for purpose k, and we do it also for different trip purposes. So this value is ultimately gives a cumulative measure where we are talking about the mode, the total and opportunities, and also the total type of trips that are being made. These are being summed up, and this is then multiplied with the proportion of the regional population. So this is one form, and then this is Handy's form, which we have explained in the last lecture, where we take a exponential of this time minus bTij, where Tij is basically the travel time from household I to supermarket j, and b is a distance decay parameter that is taken which is equal to 0.52 calculated from local travel diaries, and this is based on survey values. This has been calculated, and this basically means that Tij is being weighted by a distance decay parameter so that its effect is different. Or if I had used changed the b value, if this is not for supermarket, this is for something else, then I could have changed the b value as well. So this is what has been used, and it's Ni is of course the time discounted number of supermarkets, and I is the origin household, and j is the destination supermarket. So this is the form that Handy has given. So these are the different kinds of cumulative measures, and then we come to the gravity measures, And we have already discussed the gravity model. Now, gravity model was first applied to accessibility by Hansen, and unlike the cumulative opportunity measured in gravity model, faraway opportunities are discounted by an impedance function. So, this is where we are formally introducing a TIJ, even though we have seen some researchers have used the travel time function, which is not as an impedance, but it in generally it was in the gravity measures takes the form where we have the opportunities then divided by the travel time, or that means it travel time is basically an impedance which is actually the far away you go, lesser is the accessibility. So, the more opportunities you have got, more is the accessibility, less far away you go, then lesser is the accessibility. So, accessibility to we could determine accessibility to employed for employment, which is basically number of jobs in zone. We can determine accessibility to shopping, number of area of retail shops. We can use this OJ value as the number of or the area of retail shops. In impedance function, we can use Euclidean distances, that means straight line distances, actual network distances, that means we can measure the actual distance along a particular route network or a road network, and then we can take travel time. We can instead of travel time, we can take a combined policy sensitive multimodal measure. That means travel time is average measure between 2 points. Now, based on the modes, this travel time will change. So, we can take a combined policy sensitive multimodal measure, which actually is travel time by different modes, and those are taken separately, and we may even include cost for that particular mode, and that together makes up one impedance function. And then there is perceived distance or cost. So, this is also could be considered in the impedance. Now, impedance function, it could be a power function, it could be a Gaussian function, it could be a logistic function, it could be a exponential, which is the most common form for this particular impedance function. That means the distance is discounted in a exponential way. That means whenever we as you know, the exponential graph looks like this, and here we see that the far away we go, then the impact actually increases. So, gravity model can be applied to measure access to facilities, hospitals, compare between network configurations. That means when we are designing an urban area, we need to or we are designing land use for an area, we need to decide on how to allocate land use at different areas and all, or we want to evaluate the effect of a certain plan. We have proposed a particular plan for an area, we want to see that how good the plan is, then we can calculate these gravity measures, and then we can see the gravity measures for different zones, and we can see that some zones have very low accessibility, then we may try to improve that. Now, here we can measure accessibility to facilities. That means if we locate the hospitals in a certain part of the city, we may find that accessibility to hospitals is very, very low in from some zones. So, that may have to be rectified. That means we have to locate some more hospitals in other areas, or we have to relocate that particular hospital. Or we can compare between network configurations. That means the network structure of the city could be also compared and said, well, this network structure is more effective, or this one provides low accessibility. In that way we can do that. We can evaluate access to employment for different income brackets. We can do effect of highway construction, and many other things could be evaluated using this accessibility measures. Now, this is the most common form of this accessibility measure, where we have AI, which is the measure of accessibility in zone I to all opportunities dj, which is actually destination attractiveness, and Cij is the cost of travel between ij, and beta the cost sensitivity parameter, and we have used the exponential function. So, e to the power minus beta Cij. So, beta is the calibration, we need to calibrate this beta value based on actual data, and Cij is the cost of travel between ij. So, it is the impedance function, and Dij is the number of opportunities in all the destinations that are there. So, j is equal to 1 to n, that means all zones which are accessible from this zone I. So, this is the basic form of the gravity model. Now, in the last lecture we have also discussed something called competition effects. That means we have access competition or competition effects, which basically means if a demand for a particular opportunity increases in other zones, then automatically the accessibility for that particular zone, for that zone that we are measuring, that actually decreases. So, to determine that what effect other zones have, we need to have a way to balance the total amount of demand and total amount of opportunity that is there. So, this is called a balancing factors approach, and we introduced two balancing factors, AI and Bj, and which ensures that the total magnitude of flow, that is trips originating at zone I and destined at zone j, equals the number of activities in zone I, example workers, and j is example jobs. That means once we have formulated that and we do it for all zones, and we see that total number of trips originating in one zone is actually ending, or suppose for a job is ending to the jobs in another zone. So, this is balancing of a gravity model, we can say that. So, we will do this kind of form of balancing when we do trip distribution, but at the same time you can see that we introduce two factors AI and Bj, where AI is equal to basically 1 by Bj into Dj into the impedance function, and this is the Dj is the destination attractiveness, and whereas Bj is equal to 1 by Ai, which is the reverse of the previous equation, and we have Oi, which is the total number of origins, and then again the impedance function. So, basically what we are doing is we are making sure that the total number of trips that are being originated, they are ending up in the same destinations, and this could be matched. We estimate for one and then we do the estimate for the next step, and we iteratively do that one after another, and then we can find the values where there is not many change after each iteration, and we can find the values of AI and Bj, which are the balancing factors. So, this is how we can also determine competition effects. Now, let us look at some of the equations developed by others who have developed this form of gravity measures for accessibility. For example, Hansen has developed this particular measure where AI is equal to summation Sj divided by Tij, and where Sj is equal to the size of activity in zone j, which we can call it an opportunity, and then Tij is basically travel time between zones I and j. B is the exponent, this exponential version of it, describing the effect of travel time between zones, and then for accessibility to employment, this beta value, this B value becomes 2. For accessibility to shopping, Sj becomes annual retail sales. For accessibility to employment, Sj becomes number of jobs, and accessibility to residential activity, Sj becomes population. So, depending on the context or what we are trying to determine accessibility for, we will use this form of equation for different purposes. So, this is the basic form of the gravity model, how it started. We have opportunity divided by the total travel time. We have discussed this at the beginning, and then this form was gradually modified over time, and Guy in 1983 proposed this particular form where AI is equal to Sj into Dij, where Sj is the size of opportunity at j, and then Dij is the Euclidean distance between home I and opportunity j, and B is again a constant, and then again people have calibrated them and have set values for this B as per the data set that they have got, and then they have also, this is one form, and then another Gaussian form was also given, which could be measured in this particular way. So, this is one way to measure accessibility as well, and then Dua and Hall has measured accessibility in this particular way, where Dj is the destination attractiveness and Tij is the network travel time. So, it is a exponential function has come. So, previous example we were seeing the Gaussian value, we were seeing some other forms, and then we see gradually the exponential form comes into the gravity model. And then Carver, Rod and Appleyard they have given the job accessibility for neighborhood in this particular way. Now, the take home from this is we see that in gravity measures, again we introduce these two new variables, where PIK is basically proportion of employed residents in zone I working in occupational class K, and where could be K is equal to 1 executive, professional, managerial, 2 sales, administration, clerical, 3 services. So, we are gradually we are now breaking the entire residents into different employment groups, and the people working in different kind of employments, and then EJK is the number of workers in zone J working in occupational class K. So, this is opportunity for that particular kind of job. So, this is the total number of people who is the proportion of employment residents for that particular job, and then EJ is the number of opportunities of that particular job, and DIJ of course is the distance or higher network distance between zonal centroids for IJ interzonal pairs. And this value, and then this is for job accessibility, and similarly for residential or housing opportunities, this is the equation that has been used, where where PIK is equal to proportion of workers in employment centers J working in occupational class K, and RK is the number of employed residents in residential zone I working in occupational class K. So, this is just the reverse of the previous one. That means, here we are distributing the workers in the different employment or in employment centers to the different residential zones, and this is just the reverse of the first equation. So, Y is basically empirically derived impedance coefficient set at 0.35 for commute trips to in San Francisco Bay Area. So, I said that we need to calibrate this particular functions in all gravity models, and in San Francisco Bay Area this was found to be 0.35 by Carvalho, Rood and Appelier. So, that is based on the data set that they used, this was the value used. But if you are developing accessibility measure for your city, then you have to also calibrate the model as per the data that you have got in hand. So, basically we see that we can also use gravity models for different groups of residents or for different purposes, and we can always have accessibility for different groups, and then we can adapt that accessibility measure and then find the overall accessibility for a particular zone. So, the final model that was is shown here on gravity measures for accessibility is where Bhatt, this was prepared by Bhatt, Karini and Mishra, and this was, and also by Bhatt, Pulgutra and Govindarajan. So, they have developed this measure, where I have talked about this earlier, that this is a simple measure. Only thing is we are introducing this composite term which includes both the travel time, travel cost and the mode that has been used. So, we see that in the T, this is equivalent transit in vehicle times. We can take transit in vehicle time, transit out of vehicle time, transit cost. This is for transit. Then for C, this is over here, this is equivalent auto in vehicle time, then auto out of vehicle time and auto cost. So, basically this we will discuss this in detail when we do the mode choice module, and there we will learn that different travel of course, when we choose a mode, travel time is a big is a parameter which influences mode choice by it's one of the most important parameters which influences mode choice, and there we break the travel time into in-vehicle travel time, that is the time spent within the particular vehicle, then the access time, that means you have to go to the parking to get your car, so that is out of vehicle travel time, or for transit you have to walk to the stop, and then waiting time at the stop. All these times are actually playing a role. So, when you break this variable of time Tij into so many components, and which is like, you know, for car, for transit, and then walking, and then maybe even for yes. So, in so many ways, then we get this Hij value, which is a composite travel impedance between zone I and zone J, and we can use that as the denominator over here, and RJ is the retail plus service employment in zone J, proxy for shopping opportunities, because they were all measuring the shopping accessibility. So this is related with shopping. So this is opportunity divided by impedance, which is a overall impedance measure calculated using so many variables. Now the reason so many variables have been introduced is whenever in a city you want to change something, that means you introduce a policy, that means parking would be costly. So what would be what effect it would have? So when we increase parking cost, then it will reduce accessibility, because the total cost for car we can have another cost which is parking. So over here we can say the equivalent cost of auto will increase by adding another variable to it, which is the parking cost, and then we can say that when parking cost is increased, then it will have an effect on the accessibility for that particular zone. So that means introducing policy measures, or we can change the number of bus stops, that will reduce my OVTT. So that means out of vehicle travel time, I have to walk very little and then reach the bus stop. So if I increase the number of bus stops in the city, then it will increase accessibility. So how policies affect accessibility, or different policies that affect accessibility are actually included in the equation, so that we can see if I change those things, what kind of effect it will have on the overall accessibility for the city. And so we can call this as the multimodal policy sensitive measure in form of a gravity model. So in addition to the gravity model, we also have something called log sum or utility measure. This was developed because one major critique of the gravity model is that all individuals in a zone, even though we categorize that into employment categories or based on income categories, more or less that group of individuals in a zone experience the same accessibility. But actually it is not. Different people experience accessibility in different ways. So in utility measure, accessibility is measured based on each individual's perceived utility for different choices. Now we have not discussed what's the utility of a particular mode, or what is the utility, the concept of utility. We will cover that in details in the next module. But utility basically is the benefit that a person can derive out of a particular choice, or the choice could be anything. Choice could be for a mode, choice could be for a location, choice, any kind of decision that you take, you compare multiple options, and then you choose the opportunity which has got the highest utility. So utility measure of varies based on many things. It based on the person's characteristics, because different people may feel utility in a different way. For example, a rich person, he will not have any increasing the bus fare will not have any effect on him. So that means that he is insensitive to cost because he has got money. So that means personal characteristics play a role, or it could be based on other characteristics of that particular mode that is being there. So all these different characteristics or behavioral measures could be incorporated when we develop this kind of a measure. So instead of just cost, we can develop a utility measures which takes into account the characteristics of the individual, the cost, the time of the particular mode, and many other things. So individual accessibility should include user characteristics like income and gender. So as I was discussing, and mode, route, that is time and cost, and characteristics similar to a mode choice model. So this is where the utility measures differ from a standard gravity measures that we have been talking about. So accessibility is measured based on random utility theory using the denominator of a multinomial logit model, also known as the log sum, as an accessibility measure. So we will discuss this in detail later on, but understand this: if I have utility for one mode, suppose this is car, and then we have got utility for bus, then utility for walking. So this all utilities are for different modes. So when we are talking about accessibility from a particular zone, all the summation of all the utilities for different modes are actually taken into consideration, and then based on that we develop that particular accessibility measure. So in a multinomial logit model, basically a logit model is a way to derive probabilities for each choice that we undertake, and that is based on utility of those particular choices. And multinomial means there are multiple options, from there we can choose one. There, of course, if I have utility of so many modes, the utility of one mode becomes UTC divided by the entire, this entire value. So this thing is summation of UTC plus UTB plus UTW. So this entire measure goes below, and this is UTC. So this, using this, we can find the chance that a person, or a probability that a person will be using the car, because utility of car divided by utility of all the different modes. So this is value is called the log sum. So log sum of all the modes, or it's a utility, it's a combined utility of all the modes that could be considered. So that is this form. N is equal to, we take again log of this particular value. So summation of e to the power vk, and this vk is the utility that we are talking about. So this entire utility, this particular value will go into there. So an is measure of accessibility, vk is utility of combined mode destination choice k for a person n. So we can choose a mode, or we can choose a mode and a destination choice together, and then again we will discuss this in more advanced model. This is difficult to cover in this particular lecture, but this basically means it's a joint choice between mode and destination. That means for a particular destination we can only have chosen a certain kinds of mode, and this joint choice is basically we could have different kinds of joint choices, each one having different utility, and using that we can derive this particular measure. So along with this, we can also go for a nested logit model. Again, we will explain nested logit model later on. And one problem of using log sum is that all choices are not available to all individuals, and irrelevant choices decreases the probability of viable choices. So that means even though we are dividing by all modes the log sum for all values, but probably for one person he may not have access to car. Why? Because he doesn't have a car. He has only access to bus and walking. So for him this is basically this measure will probably give wrong results. So finally we arrive at this particular measure, which is called a time space model, where we create a space-time prism as drawn over here, and this measures a part of activity based modeling where time is introduced into accessibility measure, because activities and individuals participating in it has time restrictions. That means a person can only participate in a particular activity if he has time for it. For example, a person is at home, so this is the space and this part is time, and then this is his office. So this two things are fixed. That means he is there at home and then he is there at his office. These two things are fixed. In between he has to go for shopping. So he can spend some time at home and then travel to this shopping destination, and then go to his, again spend time and travel and then go to his office, and then spend time at his office, and this is that particular way. Or he can spend more time at home and then he goes to his this shopping, where he can spend little time for his shopping, and then he goes to his office. So this particular way the trajectory takes the shape of a prism, and we can actually determine that which each prism has got a different utility score to it, because we measured the total opportunities that are available, what time is available to a particular person, and based wherever which combination which gives him the maximum utility, he will choose that particular combination. So time geography theory by Hagerstrand, which he prepared in 1970s, he says that space-time prisms can be used to describe travel pattern, as I just explained. And this can be also considered as accessibility measures, since they define potential opportunities that can be accessed using different constraints. So that means I have certain constraints that I have to be at home for a certain time, I have to go to my office at a certain time. So these are the constraints. Based on that, I can determine my trajectory in space and time. So that actually is the time geography theory, and this could be also considered as an accessibility measure for individuals participating in different activities. So this is not a standard mode choice or a standard 4-stage model that we are discussing in like we have number of trips are generated, then person goes to a particular zone and then he chooses a mode. Not in that way. This actually talks about what activities does a person do throughout the entire day, and then when he chooses to go to an activity, and what time he wants to go there, and how much time he wants to spend there, how he wants to organize his entire day's time. So this is this activity based approach to modeling, and this is what is considered in this time space model. So in those activity based models, this kind of accessibility measures are used. So time space measures are also linked with utility measures. Utility is estimated for an activity program, that is trip and activity combination, out of a set of activity programs. Like I said, that there could be different combinations of trips, travel times, and what kind of time you spend for that particular activity, like shopping. And different household members will also have different accessibility. And the primary challenge to implement this type of measure is data availability, because you require a huge amount of data to understand the travel patterns of each individual. And then because different people, different age groups, gender groups, income brackets, and based on different family structure, people have different ways people do travel and they make choices. So that is how this actually plays a role, and this kind of accessibility measures could be also created. So these are advanced measures. We would discuss them later on when we will discuss activity based models. So these are some of the references you can look at. You can study some of these papers as well as some of these books. So to conclude, accessibility is measured in different ways. The form of the measure is closely related to the modeling approach adopted and data available. So depending on what we are trying to do or what kind of model we are trying to develop, based on that we will choose that kind of measure that we use. Gravity based measures are most popular and can be formulated relatively easily, and then accessibility measures are incorporated as the main location characteristics in various components of land use transportation modeling framework. So this actually gives the characteristics of location for a particular area. So that means that this is sort of gives the attractiveness for a particular area, and accessibility is also used to measure another important location characteristics, which is land price. So the next module, next lecture will be on land price. There we see that accessibility plays a large role. Thank you.